Monday evening to you. This is December 30th edition of the map discussion. We have the satellite image, infrared specifically. You can see the system that caused some severe weather across the deep south and southern Mississippi River Valley into the Carolinas has now exited the continental United States. The next eye catcher is over across the upper Midwest, the upper Mississippi River Valley. This is causing some rain and perhaps some snow on the back end of that system. This is expected to slide east, and behind it, some cooler air. So let's take a look at the forecast. But first, let's take a look at our maps. The 300 millibar map, this is up towards the top of the weather-producing atmosphere. This gives us a very good idea of the flow of the upper levels, how storms will follow, or what path they will follow. Notice that it's pretty much just about, with maybe a slight northwestward component to the wind flow, but it's pretty much across the United States. Some enhanced flow across the Intermountain West, extending into the southern plains. And then you see that storm system. This was analyzed at 7 a.m. Eastern Time this morning. If we go down to the mid-levels, you'll see that mid-level cyclone across southern Canada, maybe the northern Great Lakes, with the trough axis extending across the southern New England, northern mid-Atlantic states, and this is continuing to move off to the north and east. We have another little piece of energy out here near the Four Corners region. This is going to slide east. This is responsible for our low pressure center in the mid-Mississippi River Valley right now. At the time I'm recording this is just about getting old data. So 0Z31st is coming out pretty soon. But if we go down a little bit lower, you can still see that cyclone at 700 millibars. This is about 3 kilometers up. You can also see this energy a little bit lower in the atmosphere that's causing some of that precipitation and rain and snow across the Iowa, Nebraska region right now. If we go down a little bit lower, there's that cyclone, that low-level rotation, that low-level cyclone across the border straddling Kansas and Nebraska, with some enhanced flow across the panhandle of Florida. On the synoptic scale, our lift, remember, is characterized by height falls. So you can see a bunch of height falls across the southern New England, northern mid-Atlantic states. This is where our rain and storms have been, our rough weather. We have some slight height falls across the Colorado region, extending into the southern plains. This is that piece of energy that is responsible for the precipitation out there across the mid-Mississippi River Valley upper plains right now. So let's see how all these things will evolve. Thing I'm going to mention is my own maps. My own maps have been written in Python using the very helpful library called Herbie. Herbie is maintained by Brian Blaylock, and Herbie is used to retrieve numerical weather prediction model data from a variety of sources, including the RAP model, the GEFS, the National Blend of Models, as well as the Euro Canadian models, and some of the machine learning output from those initialized models from the Euro and the GFS. And it is a Python package that I have used for some time now, but now I'm just getting used to its capabilities and making my own graphics with them, and they're not perfect, as you'll see, but right now they'll do. But yeah, this is a very, very good package. If you are into programming and numerical weather prediction, then I highly recommend this package. There's really nothing like it. So here's one of the capabilities of that Herbie Python package maintained by Brian Blaylock. You could download particular model data and mix the models together. So in this case, what I have done is I've used last night's and yesterday morning's run of the GFS. I mixed in some last night's run of the GraphCast, which is the machine learning model version of the GFS, or it's a machine learning model that has GFS initialization, as well as yesterday's runs of the GEFS. And I've averaged the outputs together to make almost a custom multi-model ensemble here. And I can very easily manipulate these graphics and the computation in the code in the Herbie library in Python. All you would need is just a little bit of math, but it's no big deal. But anyways, this map here is surface pressure in the colors, and the for emphasis, the thin black lines. The thicker black lines is the 500 millibar pressure geopotential height. So here you can see a trough with a surface low pressure center under it, and you can kind of see that when these two, when one becomes over the other, that's when the system will start to what we call wind down or dissipate. But this little piece of energy here that you saw in the maps from this morning, that's the low pressure from the that's a surface response from that piece of energy over the Four Corners region. And you can clearly see these on these maps. So if we push this forward a little bit, by tomorrow morning, a low pressure center should be somewhere near the border of Illinois and Indiana, with the some precipitation attached to it. We will see that in this shortly. And you can see the very pronounced upper level trough associated with this. This will push east through the Appalachian Mountains, and as it does so, some precipitation may fall across the southern Appalachian Mountains. It might initially be rain, but it might turn to snow on its exit tomorrow evening as it approaches and slides off the eastern seaboard. But going a little bit further down, this surface high pressure in Canada, this is going to start to leak some. I say leak. This is going to start to push some cold air into the United States, as we'll see momentarily. But that system goes off the coast. The next system that we should keep a lookout for is January 4th. This is at 7 a.m. January 4th. And you can see an upper level trough is starting to develop across the Intermountain West, and some surface response, surface low pressure might be developing across the Front Range of Colorado. This is going to push south on the 5th, and another little storm system in the southern plains will take shape over high pressure. This is kind of like the signature where, hey, we got low pressure to the south, high pressure to the north. Will these two slide east at the same rate? And if this low takes a particular path that's more southerly, then this spells some snowstorms across the eastern seaboard. However, this particular model run of my model run, does not have that happening. It has the low pressure center going across the Ohio River Valley, and this is on the 6th of January at 7 a.m. Eastern time. This might have some snow across the southern Great Lakes, but it should be mainly rain, pretty much south of that. You can see this also upper level trough that's extending from the upper Mississippi River Valley down towards the south west, across the Four Corners region into the desert southwest. So for precipitation, something else had to be done. I just have the previous two runs of the GFS as well as the yesterday morning's run of the GEFS, and it has been averaged together particularly with particular weights from each model. And because of with the GFS influence, the GEFS influence on the precipitation fields, I don't really go far with these because it averages out, and it is, you'll see it, but there's really not a lot of information or useful information after about a few days. But what this shows is that low pressure center across the mid Mississippi River Valley with the precipitation across southern or pretty much South Dakota. But this was from this afternoon. If we push this ahead a little bit, we can see that this low pressure center deepens, as well as the precipitation north of it, with snow on the back end and rain and ice on the north and southern ends. This slides across the Ohio region, the upper Ohio River Valley, slides eastward with some snow possible, maybe even extending into the southern Appalachian Mountains. This brings precipitation across southern New England into places like Boston and into southern Maine by Wednesday morning at 7 a.m. And then next, that high pressure center, as we saw in the previous maps, takes hold across the central and eastern parts of the United States. And, if you've kept an eye out for the Pacific Northwest, they're just getting deluged with rain and, more rain. But high pressure east of the Rockies takes control of our weather. So this particular graphic is from TropicalTidBits.com. This is the GEFS mean 2-meter temperature anomaly difference averaged over 5 days. So again, this really gives us a picture of where the air masses are, warm air masses and cooler air masses relative to the time of year. So relative to the time of year, the vast majority of the eastern half of the country is warmer than average. Here's that cold air that's been locked up into Canada, southern Canada. We noticed on our forecast maps how we'll have another storm system take shape over the next few days. And what happens to the temperatures as we push this forward in time is those storms allow this cold air to be brought into the eastern half of the United States. So the vast majority of the eastern United States, especially the upper plains, the northern plains, will be colder than average between January 4th and January 9th. So days 6 through 10. And the GEFS, the Euro, the EPS, and the CMCE all have the same type of story. So it doesn't really matter what I showed you here. It's going to be the same, which means that those colder air masses in southern Canada will be pushed and forced its way through And again, when we have cold air replacing warm air, we'll have some fireworks. Right now, because of the the longer range models, they averaged out a bunch of details, but it still gives us an overall picture of the synoptic scale, which is the focus of this channel. We do have another developing system across the southern plains, getting into the new year. Thank y'all for watching. Again, if you're into programming, especially with Python, check out the Herbie Python package. It is very well maintained and it's open source. But that does it for this video. Thank y'all for watching, and I will see you in the next one.